Alright, let's look at the homework 16.5, problem number 7. Alright, so let's check to see if this is conservative. Alright, so I'm going to just compute the curl of f. Alright, so this is going to be, here is vector I, vector j, and vector k. And we have a partial with respect to x, and a partial with respect to y, and we have a partial with respect to z. Alright, so x first component is e to the yz. Second component is xz e to the yz. And the third component is xy e to the yz. Right? So let's compute this. First component, so hide the first column. So partial of this with respect to y. Alright, so this is going to be actually, we have to use the product rule. So derivative of that is going to be x. Then you have times e to the yz plus we have xy, and derivative of e to the yz with respect to y would be z times e to the yz. Right? Then we have to subtract, right? So we have to take the partial of this with respect to z, right? So product rule. Derivative of xz would be just x, right? And then e to the yz, right? And plus, but there's a negative sign, so it's going to be minus, right? xz times derivative of e to the yz, which is going to be y e to the yz. Alright, let's check to see if it's actually 0. So you can see that this guy and the same thing with the negative sign. And these are, order is a little bit different, but these are the same thing with different signs, so they cancel out. So you get a 0 for the first component, looking good. Alright, how about the second component? So it's going to be negative. Alright, so we're going to have to do, let's see, partial of this guy with respect to x. That's going to be simply y e to the yz, because that's just going to be a constant, minus, right, partial of this guy with respect to z would be e to the yz, but because of the chain rule, multiply by derivative, partial derivative of that with respect to z. So it's going to be y here, right? So we got that. And it looks like we got a 0 there too, so cancel those out. Alright, and the last component, let's see, so we're going to do a partial of this with respect to x. Alright, so we're going to get z e to the yz minus partial of this guy with respect to y would be e to the yz, and partial of yz with respect to y would be just z. Alright, so you can see that those cancel up. Alright, now we know that this is equal to the 0 vector. Alright, so we know that a vector field f is conservative, so we should be able to find the potential f. Alright, so let's do that. So if you take the partial derivative of f with respect to x, we are supposed to get first guy, so you have e to the yz. Alright, so we can find the original function, right, by just taking the antiderivative of this guy, e to the yz, with respect to x. But luckily, e to the yz is just going to be a constant. Its antiderivative is going to be just x times e to the yz, right? And then you might have some constant plus some constant, but since the y and z are considered to be a constant, so you might have a function of y and z. So I'm going to call it g of y comma z. All right. Then we can check the partial. So we take the partial derivative of this function with respect to y, and which is going to be, so partial of this with respect to y would be xz e to the yz, right? And a partial of this guy, so we have partial of g with respect to y, right? Then we have to make sure that this is going to match this second guy right here. So you can see that this is going to be xz e to the yz, right? So we have a term here exactly matching term here. So we know that here there's nothing else, so we know that partial derivative of g with respect to y would be 0, right? So this tells you that g is going to be a constant function. I should say g is going to be, actually, could be a function of z, because z is considered to be a constant too. All right, so now we have here, we thought that this is going to be a function of y and z, but it's actually, there's no y, so it's going to be a function of z. All right, so we take another partial derivative with respect to z, right? So this is going to be, if you take the partial of that, you get the xy e to the yz, right? Then we have a now derivative of g, so g prime of z, right? And this has to match the third component, which is xy. Third component is this guy right here, right? So we have e to the yz, right? So again, we have these terms matching exactly. And then there's nothing else, so you have g prime of z is equal to 0. So by taking the antiderivative with respect to z, we know that the g of z actually happens to be just going to be a constant k. All right, now we know exactly what this is. So potential F is going to be x times e to the yz plus some constant k. All right, so let's type it in. All right, x times e to the yz plus some constant k. All right, so let's check the answer. Submit for testing. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.